curse of Windows 95 come back to haunt you?
Yes, yeah, curse of Windows basically, yeah. The version doesn't matter, it's a curse. Right? Okay, so hello everyone, thanks for coming. So my name is Chandru, I work for EE. So it was formed in 2010 as a 50-50 joint venture between what was then T-Mobile and Orange, two separate companies. So it owns and operates the EE, T-Mobile and Orange brands. So it's one network which is operated by EE, and there's 3 brands riding over it. And we are the first and still the only 4G operator in the country. So eat your heart out, Vodafone and O2. We got there first. About my team, so I've got there are about 9 people, 10 people including me. So we've got one guy who's a device hacker, 4 of them who are really telecoms experts who do a bit of Erlang programming, but they're not real Erlang programmers, and I've got 4 full-time Erlang programmers. That is basically a map of our network. I've taken all the names out because otherwise security will kill me. So all the green dots are basically Erlang nodes. Yeah, I just generated this figure using GraphViz, but and the blue ones are core network systems. So if you see here, it begins here with the handset, that's the internet. The picture's a bit too big, you can't see it clearly, but as you can see, we've got a fair few number of systems built out over the years. So, just to, I'm going to talk about a few of the systems we have, what we've done so far, a few lessons learned along the way, building some high volume systems. And I guess the interesting thing will be, ask me questions. Probably that way I can really tell you what we've been through. So to give you an example, what we call the AAA for mobile data. It's a system, so basically every time you turn on data on your handset or your smartphone, if you've got, as soon as it turns on, it attaches to the network and it has to get an IP address first thing. So this system handles all of that. The protocol used is Radius between the packet gateway, and it proxies these messages to a bunch of downstream systems so that they know the identity of subscribers. It's built up of about 20 Erlang nodes all working together. Looks roughly like that. So we've got, the GGSN is really the packet gateway in the mobile network. So you've got these, sorry guys. You've got these Radius nodes which actually handle the incoming messages. They look up a subscriber database, which is also written in Erlang using Amnesia. The session databases maintain IP address pools, so there's a bunch of pools. And then they pass it on to proxy nodes, which act as a packet amplifier. So that you've got about 6,000 packets per second coming in, and outgoing is about 25,000 packets a second.
What's the size of the subscriber database? How many people?
At last count, there's about 80 million records in it.
80 million?
Yeah. But we've dimensioned it for about 200 million, so we're quite hopeful we'll become the monopoly in the country. So that's the real-time subscription database I was talking about. It's based on Amnesia. We use about 8 Erlang nodes, not a lot, and it handles roughly about 6,000 lookups a second. And I think CPU utilization on those boxes is about 5–6% at peak. And that's the architecture. You've got 4 nodes, fully replicated Amnesia, so it's split across 2 sites. So a pair of nodes stores the entire subscriber database, and we just use standard fragmented databases. So the replication is using all native RPC for replication, but for all queries, we've developed our own RPC mechanism because native RPC is too heavyweight and not very reliable on the heavy load. And there's a set of interface nodes, as we call it, to which all the clients talk. This way it gives us a lot of flexibility in taking nodes down for maintenance if we had to, and these broken something. These basically have the intelligence to sort of form pools of connections, do failovers and all that without the clients noticing anything going wrong at the back.
Clients in that sense are other requesting systems within your network?
Yeah. So, yeah, all the other green dots I showed you on that map, it's those, yeah. Really the biggest or the most complicated system we have written using Erlang is what we call the PDF, the policy decision function. As you can imagine, we've got 27 million subscribers, and all of them are, well, the phones are very busy data users, if you like. So even while it's in your pocket, your phone's busy transmitting and receiving data. It's doing a lot of stuff. Our radio interface is a finite amount of resource. You know, we have to sort of share it among all the users equitably. Obviously, the more you pay, the better service you get. So really what this PDF is doing is controlling your experience while you're attached to the network. So it's handling all the signaling from the core network about when you're trying to do data monitoring, how much you're using. If you've got a fair use policy on your contract, it policies that so that when you hit it, you don't get that high-speed data anymore. You just fall down to sort of browsing an email, and you don't get any of the fast streaming of video. We do redirect you then and say, would you like to buy a pass for additional fiber? And again, you know, like I said, in 2010 we merged Orange and T-Mobile. So since then, because I come from the T-Mobile side, so slowly the stuff we've put in has been spreading across to the Orange subscriber base as well, like a virus, slowly but surely taking over stuff. So there's a lot of disparity we have to handle in terms of which subscribers we are serving and what user experience they're getting. It's currently made up of 16 Erlang nodes, but this is changing constantly. So, I mean, high-level view, that's really what it is. So there's, again, GJSON, like I said, it's the packet gateway. There's a bunch of nodes terminating diameter, which is again a protocol within telecoms. If you guys are familiar with telecoms, you'll know diameter. But otherwise, it's basically a binary protocol, fairly simple, really, to understand. And OTP's got a built-in stack for that. Those talk to so they do the protocol decoding, talk to internal core nodes, which do all the heavy lifting of the business logic, figuring out what's happening. There's again a PDF database, which is again Amnesia, but we're suffering from that. We'll come to that later.
What's the difference between GX Lite and GY?
So GX and GY are two different 3GPP interfaces. Now 3GPP is the body which standardizes telecoms protocols. GX and GY are different protocols. GX is what we call the control plane, so it tells the GJSON what policy to apply. GY is the charging interface, so the charging reports come down here. And GX Lite is basically a lighter version of GX. And we've also got a bunch of mediators, all online charging written using Erlang. They act mostly as a protocol converter. They take one protocol in. Because our IT systems are traditionally a bit slow to evolve, they're all written in Java or C++ or something like that. So typically their release cycles are 3 to 6 months if you're lucky. And if you put in a request at the beginning of the year, hopefully by the end of the year it'll be in your release. So what we tend to do is sort of put a layer of Erlang nodes between our core network systems and all the IT systems that we can change at will and allow networks to move ahead as quickly as we want without affecting. So initially when we first did this, it was in 2008, there was no diameter stack in OTP. So we bought one from a guy called Thomas Lindgren. Some of you may know him from his interactions on the mailing list. But we are slowly migrating to the OTP diameter app because it's actually, the one in OTP is much, much nicer and it works really well. Another system called a third-party gateway, it handles all the bulk SMS traffic from third parties. So all the spam you get on your phones goes through Erlang, if that makes you feel any better. And it handles upwards of 100 million messages a month, but again, that's not a huge figure really, I mean, compared to the billions of SMSs which go through. But again, we're a small team, so we haven't been pushing it hard enough. This is an interesting one, roaming call control. So basically every time any of our subscribers go abroad and they try to make a voice call, there's an Erlang system making decisions about, do I connect the call, do I divert them to some announcement, or do I drop them? We are pretty much one of the, if not the only one of the very few networks in the world which has this capability, thanks to Erlang, because most others, roaming fraud is a big thing, is a big loss for mobile operators, and not many operators have anything to deal with this problem. We can do this purely because Erlang really gives us the capabilities to. So what we do is every time a call is being initiated, we get a trigger from the network telling us who's calling, who, and in which country they are. Using those three, we can make a decision on. So if you're in Pakistan and trying to call a premium rate number in Nigeria, we reckon that's probably a fraud call and not a legitimate one, and we drop it. So I mean, in our view, Erlang's pretty awesome. Why? Because it really lets us do rapid development and go to market really quicker than people can make a business case for it, or produce the correct. It's actually faster sometimes than if they ask us for a service and we say, okay, what sort of reply messages do you want to send the customer if we hit certain cases? By the time it goes through brand and legal, it takes 2 weeks, and we've got the service ready, deployed, saying, okay, when do you want to go, give us the messages. It's easier than other languages to get things right. I first wrote easy, and I thought I should probably qualify that. Because while the simple things are really quick to write, if you're really looking at something high volume, really mission critical, it takes a bit of time and effort. You can't, there is no real shortcut, but I think generally, in my experience, you can do the same job much faster in Erlang. I mean, obviously, you can do pretty much anything in any language, and the likes of actually Google are probably testimony to that. For the same amount of input, you can get your output faster of the same quality. And it's free, this is great. We get a lot more value out of it than we paid for it. It's brilliant for implementing protocols. I mean, we can turn around support for new protocols in days, literally. There is the binary syntax and support for. I mean, recently, especially the support for SCTP or TCP, which is awesome. It's a gift, and it comes with a built-in database, which for most medium weight applications, I think Amnesia is pretty good. You start going into heavyweight database stuff, Amnesia is not really suitable for it. And and in the PDF, for instance, I talked about, we're looking to move away from Amnesia because we're starting to suffer from its limitations. And again, there is a largish pool of active developers, especially on the mailing list. It's not as easy to find an Erlang developer as it is maybe to find other languages, but still I think it's not that bad. You can find people.
It's not Haskell.
Yeah, exactly. Yeah, it's much better than that. Yeah. So just to illustrate how quickly we can do stuff with Erlang, so we were suffering from this fraud called Symbox fraud. And basically what that is because international calling over mobiles is pretty expensive, or say international calling is expensive. So, so what people used to do was they get these devices called Symboxes. Like so, if somebody wants to call from India to the UK, for instance, now that's quite expensive if you did it fully over the proper GSM networks. So instead what they did is they started routing calls voice over IP to a device located in the UK, and that would break out through the Symbox. So to us it would look like a local call, a mobile calling a local, local number. And people were especially abusing price plans where it was being sold with bundles saying 500 minutes for a tenner a month. Now, so that was being abused a lot. So we heard about the problem, and really within about 2 weeks we had a fully working solution, which what that was basically doing was every 5 minutes taking a CDR feed out of our rating systems and looking for calling patterns. Now if you're a typical mobile user, you probably won't call more than 10 different, or let's say 50 different numbers in a month. Whereas with these Symboxes, because they put call after call after call which have no relation to each other, you can literally, by analyzing about an hour's worth of CDR data, tell whether this is actual mobile user or is it someone trying to do this fraud. So within an hour of these devices being put in a Symbox, we used to get enough data to say, okay, you are a fraudulent user. And immediately, we didn't actually disconnect the device, because that would be, I think, contrary to all the legal stuff in the contract. What we did was we removed the data bundle on their account saying, well, you've exceeded your fair use, so you can't have it anymore. I think, literally, within 2 weeks after that, fraud on the T-Mobile network literally just went down to almost zero. And they moved on to the other 3 networks in the UK.
Success.
Yes, indeed. I mean, double whammy. We save money, our competitors lose money. So, a bit about lessons learned. I mean, there aren't any great insights, but some of these is what we learned the hard way by actual having outages in the network. And this is a funny one. Proclip spawn. You guys probably know this. Spawn a new process. It can be quite harmful if you're operating under load, because if you have a bug which manifests under load, what Proclip spawn does is when a process crashes, it produces a nice formatted error report in your SASL logs. Now you have about 5,000 of these a second crashing out. Error logger quickly builds up a huge message queue, and your Erlang node is pretty useless after that. Yeah, I mean, like I said, we found it the hard way when there was an outage going on, saying, what the hell is happening? And you look at the process listing, and there's error logger with about 3 million messages in its queue. So we quickly had to fix that. I mean, the solution was fairly simple, just use Erlang spawn. At least your processes can crash because of the bug, but they won't affect everything else. This, again, I don't know if you guys saw the news. We had a couple of hours of outage on our 4G network on Monday during the busy period, which was a bit of a bummer, but we're still the first to the market and it still works. So yeah, that's how I justify my job to the boss anyway. But at high volumes, what we observed was we were able to receive data on the socket, but actually GenTCP send was blocking. Now, again, there were thousands of processes being spawned every second, and the expectation is that they'll do something and they'll die after a few milliseconds or maybe a second. And they were not, because GenTCP send was blocking for some reason. It couldn't send data out. And pretty quickly we had about 200,000 processes in the node and counting and slowly grinding to a halt. And when that happened, Amnesia decided that it wasn't going to play ball as well. So by the time, yeah, it took us a couple of hours to isolate the traffic away from the system. and then recover it, and then, yeah. So I think you got to be careful really that if you're doing GenTCP send and you're expecting that to finish quickly, I think you better be careful in a high volume system.
You don't know the cause and reason why it was blocked?
We know we had networking issues. So this was between two shared Amnesia databases. And it was on that link, we had some, we know we had, it was actually a fiber brick. Somebody went and dug it up. Basically.
Okay. Yeah.
But again, our networks, our data signaling network is built to cope with that sort of stuff. Traffic gets rerouted and stuff. But I think they came back and said it took about 39 seconds for it to fail over to the other route.
Yeah.
But
It's about the right time.
yeah, but that was enough time to screw the system up, really.
So congestion management can kick in and slow everything down at the TCP layer, but it should be.
Yeah, I mean, I haven't got to the bottom of why this was blocking, but I know for a fact that this was what was causing the process to not die, because it was pretty much stuck at, yeah, I've done all the work, here's a response, and stuck there. That's literally the last statement in the worker function to say, well, send the response, I will die, and that wasn't happening. That caused the process build up. And, I mean, there was another reason, really, to be frank. We were using, there was a library I wrote, which is, yeah, it's a bit embarrassing, really, but.
It's okay, it's being recorded.
Right, okay, excellent. Yeah, I can make a fool of myself for posterity. So Amnesia has this thing called fragmented, well, you know fragmented tables.
Yeah.
But fragmented tables doesn't have ordered set semantics. But we really needed ordered set semantics on large tables. So I said, yeah, I know what, I'll write an Amnesia activity callback, which every time somebody does an index read, for instance, it'll just go scan all the tables, figure out which one is actually the first, because each fragment, we made it out so that it was an ordered set. So I said, all I need to do is compare across all 16 and I'll pick the first one out of that. Now, obviously at high volume, it just blew up, and I should have seen that, because when you're doing index read on a table, it takes the whole table lock. And that means, and because we had this 39 seconds of outage between the two DB nodes, we had transactions piling up, and Amnesia didn't recover after that. Message passing, I think, is dangerous. It's actually very powerful and intuitive when you're first building. I mean, when I first encountered Erlang, really message passing was really what made me fall in love with it, because it's just a very intuitive way of writing code. You want one entity to talk to another, you send it a message. Hey, you know, how much more? Yeah, what more can you ask for? But it's very, very easy to overload a system as well. It's incredibly easy, right? And if you're not careful and you haven't thought through how all the messages are going to flow through the system and exit it, more importantly, you can kill yourself very quickly. Obviously, it needs a lot of load testing to find the flashpoints. You need overload control. I suppose we need some solution to it. I've asked this a couple of times on the mailing list, and most of them the response I got back was, well, you should design it properly then.
Have you found any good tools for seeing what your message rates are and what the message latency is?
Not really. I think that's another bit, that the tooling support for the Erlang system, I think, is actually not
strong
there.
in some areas, but non-existent in others.
Yeah. I mean, there are some libraries, I suppose, on GitHub, and you can go and look for it, but nothing which really stood out to us as something which would really work. And the important thing for such tools is really they should work under load. When your system's going wrong, that's when you want it to work. And, you know, if it works in a toy system, it's not really useful. And no, I haven't found that. I think it's a good opportunity for someone who wants to write something and sell it. I'll buy it. within reason, because the price is good. But I think, you know, some things I personally feel would be interesting are stuff like bounded message queues. It would be nice to be able to say, if this process message queue ever exceeds 1,000 messages, kill it.
Chandru, is it better to use load regulation when the requests are actually entering the system?
Yeah, that's true. So that's the bit about needs careful design.
That's really
Yeah, you should do that. Again, but
again, I mean, this is an issue which shows up only with multi-core. If you go back to the good old days,
yeah,
this was a very rare problem with multi-core.
Yeah, with multi-core you've got stuff happening all at the same time. It's true concurrency. So, or I mean, just while I was writing these slides, I thought, hey, why not have message queues in as an edge table? I mean, as an option. When you spawn a process, say, actually, you know what? I want the message queue for this process as an edge table. That way, I can, if it's building up, I can actually go and do queries on it to see what kind of messages are building up and inspect it properly. In the worst case, do it, select, delete, and just wipe the bloody thing off. And saying, and you know, quick way to recover without bringing the whole system down. But I don't know. I suppose it's a lot of work. I'll probably pop it on the mailing list and see if anyone bites. Amnesia limitations. Yeah, we think Amnesia is great. I mean, obviously, you see our subscriber database is in Amnesia. You know, we've pushed it to about 80 million records. I'm sure it'll take more. You know, just add more fragments. It'll work. But again, our subscriber database is you know, there's 500,000 writes on it a day, but there's probably 500 million reads on it. So it's perfect for that. I'll keep using it for subscriber database. But for something like our policy engine, there's lots of writes going on. The reads and writes are actually very evenly matched. And Amnesia is really not built for that. It, yeah, its biggest weakness is if you put it in a single node and just throw stuff at it, it'll work. You distribute it and throw stuff at it, a lot of writes especially, it can break pretty quickly. And it's hard to recover. Partition networks are a pain to deal with because you need a restart. I haven't tried those big as net split stuff, but I'm not sure how well it will work in a heavy load situation. So I mean, one of the things we're considering is moving to React for something like that. But again, you know, small team, no time. So current challenges we're facing. You know, I'll be open about this. We lack comprehensive automated test coverage. A lot of it, we being pretty opportunistic about it to say, oh, there's a new problem that the business has. Let's quickly solve it. We have a test plan which gives us end-to-end testing. So we have that luxury to say, actually, can you test it for that? And it works for all the positive cases and maybe a few negative ones. We've sort of managed to do that till now, but it's reaching a point where really we're not able to move forward without actually building this up. So actually we've got the likes of Rudolf and a couple of his guys in South Africa building this up for us at the moment. So that's pretty good. I think in a few months' time we'll be in a much better situation with respect to and it slows down our development cycles as well, as especially if it's a complex system. Some of the simpler ones, you do it once, it's verified, you know, and nobody touches it for years, that's fine. But a system which is undergoing heavy change constantly, this is a bottleneck. Scalable database would be nice. It's probably React. We haven't tried it yet, by obviously keeping an eye on what's happening within the industry and the community. So we think React's probably the way to go. We're migrating all our code base to Git from Subversion. That's throwing up its own challenges. We liked most things about Subversion except the merge support. That was okay. Yeah, or the lack of it. But moving to Git has actually thrown a different kind of problem in that with Subversion we get nice, we can embed the Subversion revision number and the Subversion URL into the module when it's checked in. so that when you compile it and load it in the live system, all you have to do is module info and you know exactly where that file has come from, which part of the source tree and which branch and all that. But with Git, all you get is a commit hash inside, and you have no idea where the thing has come from. I mean, you can find out using the commit hash, but that's nearly not as intuitive as having a subversion revision number, which we can quickly.
Tags.
Tags. Right, how does that work?
Talk to me.
Okay, right. Yeah, it sounds like a good idea. Documentation. Francesco knows all about it. I mean, there isn't any documentation really.
Read the code, come on, it's your man.
Yeah, that works to a certain extent. I mean, beyond a certain point, especially when we're trying to bring on contractors when there's this new work and quickly want to get them productive. It's a hassle because they keep asking all these questions and you can't tell them RTFM. You know, you have to spend time with them, so it's a bit of a problem. Everyone knows this.
It's intent you want in comments.
Yeah.
You read the code and read what it does, but it's the intent of
yeah, exactly. I mean,
what they were trying to do is important.
You're right. I don't think I'll still put comments in my code, really. I think I've come out of the mailing list saying comments are a waste of space. But
all my developers
it hasn't been
complain.
career limiting so far, but we'll see.
All my developers complain because I reject their code and there's not comments in it.
Excellent, okay. Well, as long as they're meaningful comments and not handles cast messages, like that's pretty useful.
I normally go for the, if it's a Git project, the syntax is normally header, 2 lines, description.
Yeah.
If I'm doing code review, I will accept anything that has a description in the Git commit in place of a description in the code.
Yeah.
Because in practice, you always distribute your Git repository with the code.
Yes. Yeah, makes sense, yeah.
And then you just use Git blame for any new shit that you don't understand.
Yeah, I mean, the reason, so when we were using, well, we're still using Subversion, the problem with putting comments in the code is if they're wrong or they're gone out of their date and I come across it, I have the urge to fix it. Oh, that's wrong, you know, but the problem is you fix it and you commit it, the version number changes. Now, if for some reason the tester or someone in operations says, oh, that particular module is, you know, it seems to be out of sync with what it really should be, and we give them this updated one, and they go, but that's not what is in test. You know, the test version number is different because you changed the comment in the code. And then it comes down to this argument about trying to explain to them, look, come have a look at our diffs if you want, really, there's no code change, it's just but they won't accept it. So we came to the point saying, yeah, okay, you know, unless it's a really useful comment, don't bother putting it in the code because it just causes more hassle down there. So that's it really. Happy to field any questions you have, but so we've grown from what was one full-time guy doing Erlang in 2000 to about 10 people doing it full-time now, including all the contractors we have. And that's a big team if you're talking Erlang actually.
But it still seems a small team compared with all the other developers.
Yes, it is.
Organisation, and
yeah.
Why is that? If you're so successful with the Erlang side, why are they still writing all this Java and
oh no, the rest of them don't do Java really. They just do. They're the telecoms guys, so they go and do iron. So where I said iron experts, these guys are developing services on the SCP.
Yeah, no, I meant the rest of your IT organisation there.
Right, okay.
All the other big apps which you're having to interface with.
I think
they can't change very quickly because they're not written Erlang.
No, but it comes down to a political battle really, and how much you're willing to fight it.